Pythagoras was a mathematician from a long time ago. This is something he came up with. It's the Pythagorean Theorem. So the Pythagorean Theorem. With Pythagorean Theorem, so Pythagorean is named after Pythagoras. Theorem is something that's proven like in a geometry class. So as you take like a geometry class, they'll go through, there's a number of different proofs you can get. I thought about showing you one in class. You can find a bunch on YouTube. But we're just going to kind of do the bare bones, like what is it? So first of all, this here applies to right triangles. So I'm going to draw in a right triangle. And it doesn't really matter what shape yours is as long as you have a 90-degree angle in there and some straight sides. But Pythagorean theorem, I'll write it in red for dramatic emphasis. A squared plus b squared. Anyone remember it? Equals c squared. So you did this last year in Math 7. With this, the part that matters is what you put in for c. Which side has to be c on my right triangle? The longest one. Perfect. That, remember the name for that? The hypotenuse. Nice. That the longest side, which is always going to be the side that's directly across from the 90-degree angle, that's the hypotenuse that has to be c. Has to be c. The other two sides are called legs, and you could put a and b there, or you could switch them. A could be on the bottom, b could be on the side. But the two shorter sides, the two sides that are connected to the right angle, those have to be a and b. If you don't know those terms like hypotenuse and legs, you might want to put it in. I don't remember if the book has questions specifically like find the hypotenuse, but it'd be a good thing to know for down the road. Hypotenuse. We just did this in my Math 7 class last week, and we had a quiz on it. The quiz was awful. And I found that the people that wrote out a squared plus b squared equals c squared on their quiz and then put numbers in, almost all of them got it right. The people that didn't write the a squared plus b squared equals c squared, a lot of times it looked like they just kind of threw up numbers on the page. They took the numbers from the problem, they put them together somehow. Please, please, please write a squared plus b squared equals c squared. It's going to take you an additional 4 seconds, but it ups your chances of getting it right exponentially. You're just way, way, way more likely to get it right. All right, I'm going to do some examples. So my example 1, there's really going to be 2 types of problems. One is where you're trying to find the hypotenuse. So that's going to be one of these. So find x, I'm going to say. And I'm going to draw a right triangle. I'd try to make yours look a little bit like mine, just that way the numbers will make a little bit more sense. And I'm going to pick a 5 for the vertical and a 13 for the base. So 5 and 13. And x now is the longest side, which we call the hypotenuse. So I'm going to practice what I preach and write a squared plus b squared equals c squared, because I want to get it right, so I look like a good teacher in front of all of you. A squared plus b squared equals c squared. If I'm looking for x, x has to go in for the letter c. So x has to go over there. And now I could write the a and b as 5 squared plus 13 squared, or 13 squared plus 5 squared. So I'm going to say that this side here is a, this side here is b, and the x is the c. But 5 squared plus 13 squared equals x squared. Close. So 25 then, 5 squared is 25. So next step, get rid of the squares. Just 5 times 5, or 5 squared in your calculator, or your brain preferably. 13 squared is going to be 169 equals x squared. To make this a little more simple, I could combine the 25 and the 169 to give me the 194. So 194 equals x squared. Now here's a place where I've seen a lot of people make mistakes. They see the x squared and they think divide by 2. You could divide by 2 if it was 2x equals 194. That would work. But it's not 2 times x, so dividing by 2 doesn't help us at all. How do you get rid of a square? Square root it. Square root it. If you look at your x squared button, if you do second and then your x squared button, it's the square root. Those two are inverses. They undo each other. So when I square root the right side, what happens there is it's kind of like my square root and my square just cancel and leave me an x. But if I square root the right side, I have to square root the left side to keep it equal. And on my screen, 13.92. We don't need to write out all the digits on the calculator screen. My real point is round correctly, and I found that that's something we struggle with here. So if you want to go to 3 digits, you'd say 13.928. If instead of that you just wanted to go to 2 digits, so you want to go here, you'd say 13.93, or you could even just say 13.9. I wouldn't round it to 14. That's maybe a bit much. But so I'm going to say x is 13.9 maybe. So leave enough decimals that it looks like you're not guessing. 13.93 would be better, I suppose. But does that make sense for example 1? Yeah. Example 2 is going to be real similar, and then we might not do the last 2 examples I've written down. I'll maybe just kind of point out some stuff about it. But my example 2, I'm going to make this one more tall than wide. It needs to be a right triangle, or you can't use Pythagorean Theorem. And now I'm going to say the hypotenuse is 13. The base is maybe 8. Mine doesn't quite look like an 8. Oh, we'll leave it at 8. So 13 and 8. And now I'm trying to find this, that vertical side. I'm going to take the extra 3 seconds and write a squared plus b squared equals c squared and try to convince you to do the same. X. Where do we put x? B. You could go in for B, or it could go in for A. So I'll maybe put it in for A. So I'm going to say my A becomes X. And it's not a bad idea to even go through and label up your triangle. I'm going to say that's A, that's B. But X has to either be A or B. And what has to be C? That's the one we got to be real careful of. 13. So 13 squared goes over there for C. So I have X squared plus B squared. Nice job for you two throwing out answers. Not B. X squared plus 8 squared. Thanks for catching that, Trevor. Now, once we have this, a good rule of thumb when you see numbers like this, always do the squaring. That pretty much every problem, your next step is going to be, all right, 8 times 8 is 64. 13 squared is the 169. Are we okay up to there? Now this type, when we're solving for one of the 2 legs, there's one additional step. What do I do before I square root stuff? Perfect. I have to subtract that 64. It might be tempting to square root everything because square root of 64 works out nicely, but it doesn't work mathematically. I can show you why if you want. But I get an x squared equals 105. Now if we want to solve for x, we would square root it. And I get x equals, with a little bit of rounding, 10.247, you could say. In my notes, I wrote down 10.25 if you want to go to a little bit fewer digits. You did round the 7 correctly, yes? Okay. Is that okay for those 2? Do you feel like you know enough? So here's 2 more examples. We won't go through the whole thing. But you could get a triangle like this. Can I do Pythagorean theorem with this triangle? No, because it's not a right angle. The example that I've written down, I made this sweet teepee for Camp Roger. I can sew. Maybe that makes me feel a little less manly saying that in class, but I can sew. But I made this teepee, and I'm guessing a little bit on the dimensions, but I'm going to guess the side of it is 13, and all the way across the base is 14. So if we wanted to figure out, we had to cut new support logs for it. We had to figure out, well, how high is it going to be? So we're really looking at, like, how high is it? Yep, which I should have threw that out there before I really drew it. But if the question is how high, what you could do is you could take this triangle and turn it into a right triangle. And it might make a little more sense if I kind of get rid of some of this. But can I say my sides are 13 and 14? Nope, I have to say my sides are 13 and nice. Because if that's symmetrical, right down the middle is going to make it so this base now is 7. Good? Yeah. So that's one example, one trick the book throws at you. Here's the last one. They give you a triangle where the sides are kind of ugly. So say something like this here. and we'll say this side here is the square root of 5, and this side here is the square root of 6. Well, if I want to go through and plug that into Pythagoras, I'm trying to find the hypotenuse. So a squared plus b squared equals c squared. When I put maybe we'll say this side's a, this side's b. When I do square root of 5 squared, you could actually punch that in your calculator if you wanted to. But even without putting it in your calculator, what is the square root of 5 squared going to be? Just use your brain. 5. Because you could say square root of 5 gives you some ugly decimal, square it, it'll give you 5. Or it's easier to look at it as though it's the square root of 5 squared, which is the square root of 25. But if you think back to what we were doing in that last step, we said that the square root and the square cancel, so that would just end up being 5. And if we did the square root of 6 squared, that's just going to end up being 6, right? And then those would equal like my x squared. So 11 equals x squared, square root 11 to get your answer. That go by too fast? Does that make sense? The real thing I'm just trying to get at, though, is that whole square root of a number squared just equals the number, because the square root and the square cancel each other out. That's it for Pythagorean theorem.